Great, great, great. So I'm probably gonna have to stand real close or just be done with it, right? Let's do like all the pseudo rock stars do and put that away and get going. I'm super excited to be here with you in Brasilia. This is my first time in Brazil. This is my first time in Latam in general. And I must say, it's been good so far. So yesterday we were in Sao Paulo, where we spoke at a PHP event, which was a lot of fun. And today we're in Python land, so it seems. I don't speak Portuguese. This will not be in Portuguese, but my Portuguese colleague taught me a catchphrase and he insisted on me saying it here. So here I go. Sorry for butchering it. E aí, galera? Tudo beleza? All right, all right. So based on your reaction, I'm going to assume that was good enough, right? All right, let's carry it on. So thank you, Eriko, for allowing me to speak here, because this is interesting for me. This is a community I haven't interacted with before, and I'm really excited to see what is going on here and how Varnish plays a part in this. Now, before I can talk about any of this, I need to establish a sort of a informal relationship with you. So what I'm going to do to break the ice is I'm going to present 3 distinct statements. And it's up to you to respond to those statements. You can do that very politely and very carefully by raising your hand, but you're perfectly allowed to use your voice and scream, shout, do whatever. So here we go. 3 distinct statements. Are we ready for this? Are we ready for a little bit of interaction? Will that work? Yeah? All right, here we go. Ladies and gentlemen, here in Brasilia, do we agree that slow websites suck? Good. That's easy to spot that we have a decent audience here. Number 2, do we agree that web performance is an essential part of the user experience? Yeah, it's a competitive market, right? If your stuff is slow, people go elsewhere. And here's the third one, slightly more controversial in my opinion. People tend to disagree, some tend to agree. Do we agree that slow websites are just as bad as a website that is down? Ooh, no, see? Some people say yes, some people say no. In general, the answer is meh. It's meh. But regardless of your opinion, here's what's going to happen. If your website is slow or it is down, you will lose money. You will lose face. You might even lose a little bit of Google PageRank. So the answer, or the question that we have to ask ourselves is, how do we tackle this? How do we approach websites that are slow? And a lot of people think in terms of what they see, what they feel, and they have the symptomatic behavior as in, let's just throw servers at the problem. If the website is slow, it's obviously related to some sort of capacity-related issue. So let's throw servers at the problem. Now, you and I all know that that is not a sustainable solution in the long run, just throwing money at a problem. I must admit, when the house is on fire and you need to do firefighting, this could be a temporary measure. But in the long run, it doesn't work. And as the famous poet Notorious B.I.G. once said, more money, more servers, no problems. So let's try to avoid that. Let's agree on that and find a different strategy, which could be identify the slowest parts and optimize accordingly. It's a very sensible thing to do, right? Like you look at what is slowing you down, you use all the tools that you have in your arsenal, you go top down, bottom up. Could be from optimizing the hardware, the network, your Linux operating system, the Python components that you're running, the actual Plone framework, the database you're connecting to, all the way to the top could be the HTML or the JavaScript that you're rendering. Do that, make it faster. But here's the trick. After a while, you'll hit the limits, the so-called point of diminishing returns. And in fact, you can't optimize your way out of a scalability problem. So after a while, you'll need something. And that could be, on the one hand, in limited fashion, throw servers at the problem, but it could also be caching. And that's the topic of today. And with caching, I love using the analogy of the boxes because caching is nothing more than storing pre-computed results in boxes for later use. That's what we're going to do. And if we look at it from a philosophical point of view, why would you render the page and waste the resources every time you request something if the data doesn't change? Why send a request to the web server? Why analyze it? Why start up your Python runtime? Why go to Plone? Why go to the database? You get the gist, right? Every single time the data doesn't change. That's what we're trying to approach here today. And that being said, again, hi, my name is Thijs. I'm super excited to be here with you today. I happen to be the tech evangelist at a company called Varnish Software. And yeah, I'm not here alone. I'm joined by fellow colleagues who invited me to come here. If you look near the exit, we have our colleague Lucas here, who is Brazilian. So So he's definitely a guy you want to have a chat with. He's part of our solutions engineering team, and he's going to say something real clever in Portuguese now.
Oh, not much clever, but pessoal, muito obrigado. Muito, op, 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 op. Aqui, opa, assim? Melhorou? Pessoal, muito obrigado pela recepção, pela oportunidade de a gente estar aqui também. Assim, não somos especialistas em Plone, mas conseguimos ser falar um pouquinho de Varnish nesse sentido, tá? E muito obrigado por toda a recepção de vocês aí. Érico, obrigado pelo suporte e estamos aqui. O que precisarem, estamos à disposição. Ok? Abraço. Valeu.
There we go. And we also have Gunnar, Gunnar doesn't sound like a Brazilian name, does it? He's German, but he speaks Spanish really, really, really well. And he's our territory manager for Iberia and LATAM. And if you have questions of any kind, the dynamic duo there would be a good match, and I'll assist as well on all things because we're limited in time. Now, of course, beyond being an evangelist, which means doing a lot of outreach, a lot of presentations, creating a lot of video content, trying to write tutorials. I'm also an author of Getting Started with Varnish Cash, which is based on my facial expression. It's an old book. It's like, shouldn't buy that one anymore. It was a great honor, though, being invited by O'Reilly, but I do have a follow-up book, which is called Varnish 6 by Example, and I have a free copy here. I brought a book. It's a 778-pager. You can see it's heavy. It's 2 kilos. I'm not planning to fly back. I brought 4 of those books, that's 8 kilos of luggage. I will put this here and deal with it. I'm going to walk out that room in about 40 minutes, and that book will be here for whoever who wants it. I wrote this during the COVID pandemics. The COVID pandemics were long. So Varnish software, by show of hands, who has heard of us before? That is nice. That's a better average than I'm used to. So we are a company that builds software-defined web acceleration and content delivery solution with a super strong emphasis on software-defined. We're a software company. We're not a platform. We're not a CDN. We make software that you can install, commercial software, but obviously we're also the company behind the open source project called Varnish Cache that so many people like and use. And if you don't use a cache like ours or competing products, you'll typically have a direct interaction pattern with your server, which is fine, which is nice, which is simple. However, under pressure, things could go sideways real quick, depending on the number of concurrent users, but also depending on the type of workload that you're requesting. If it's computationally heavy, it doesn't take a lot of users to tumble. So typically, you put a cache in between, and this is how we operate under the form of a reverse caching proxy. We place ourselves in between the user and the application, act on behalf of the application, and deal with every single user request. If we have it in the cache, we'll serve it. If we don't have it, we will fetch it from the application. The application, for all intents and purposes, being Plone, right? So, and Volta. This doesn't happen in a void or in a vacuum. We're not reinventing things. We're not trying to pretend that we have all the knowledge and that we invented all of this. We're basing ourselves on pre-existing standards, the HTTP caching standards that come with the protocol. Who here has seen this one before? A cache control header. Should be a very sensible header, right? It pretty much says how a cache, and could be various caches, could be the browser cache, could be an intermediary cache, has to behave. The max H directive pretty much says how long it can be stored in the cache for. It's a pretty basic one. The opposite would be private no cache, no store if a specific page does not belong in the cache. And the fun thing is, yes, we respect all those caching directives, all those best practices and conventions. I'm pretty sure our competing products and projects do that as well, which makes it very easy to cache static HTML pages, PNG, CSS, JavaScript, fonts. Everything static is super easy. But here's the trick. Varnish does not cache when cookies are used, which is kind of interesting. It's not a bad thing, though. It's a conservative thing. And it doesn't cache either when it sees an authorization header. Also very sensible, might be weird, but sensible, because it indicates that whatever you are seeing is very personalized. A cookie indicates a personalization for your eyes only. And by just, without any further recognition, just caching, this could be a tremendous danger. And there's terrible war stories about all of that. I've heard a story about some sort of a tax office for a country caching tax returns. So the poor bastard who logged in first got his tax returns cached. That is not something we want to do. So by default, if we see a cookie, we don't cache. Which brings us to an interesting point of reflection. So I'm going to make a statement, I'm going to ask you a question, and then we'll come to a conclusion on this very topic. The statement, I'll repeat, is Varnish does not cache when there are cookies. Statement. Question, do we know any modern day websites that don't use cookies? I'll scan the room. I'm scanning the room. Not a lot, right? Not a lot. So can we then come to the obvious conclusion that Varnish cannot be used in the real world? It's kind of controversial, right? The answer, obviously, ladies and gentlemen, is no. Varnish is definitely ready for the real world. And when cookies are in play, it's just a matter of dealing with them properly. And that goes beyond what you can do with the basic HTTP cache control headers. And that's where VCL, or the Varnish configuration language, comes into play. Who's heard of VCL before? Just for me to gauge the audience. It's pretty decent. It's pretty nice. Wasn't expecting it. So VCL, the abbreviation, is short for Varnish Configuration Language, which is a domain-specific programming language. It is only applicable within the domain of Varnish. You can't use VCL to write front-end code or anything like that. It has a curly braces style, unlike Python. Not really a Python expert. And it is used for all things caching, controlling incoming requests, dealing with responses, doing manipulation of sorts. Could be headers, could be the payload. Deals with all elements of caching, of what to cache, what not to cache, how long to cache, where to cache, when to cache. And then all the extra behavior that I would catalog under edge compute logic. It is very, very fast. It doesn't slow you down. It's not a scripting language. It's an actual programming language that gets compiled. Or should I say, first transpiled into C before being compiled into machine code and attached to the runtime as a shared object. So it is lightning fast. It is also another top-down programming language. So that means if you are planning to use Varnish and you're going to write VCL for Plone, it's not that you have to start from scratch. There is pre-existing behavior, and not accepting cookies is one of those. And then you just have to hook into what we call the finite state machine to change the behavior and to customize it to the needs of your application. This is the finite state machine. It's nothing more than a flowchart with different states. Every state represents part of the cache execution. It has a semi-cryptic name, which makes sense to some sort. And that you can extend by writing a subroutine in VCL and putting your logic there. And that's what we're going to do in this presentation. So I'm going to take you through maybe two scenarios. Let's do a cache miss first. Typically, I would point, but the screen is a bit far off, so let's use our imagination here. You start with start, left upper hand corner, and you receive an HTTP request, which brings you to VCL recv. Recv stands for receive. There you apply the logic, and then you decide whether something is cacheable or not cacheable. Cookies, authorization headers, checking whether it's a get or a post, all of that happens there. And then when we decide that it's cacheable, we're going to look it up in the cache. And to do so, we need to create a hash key. So we enter VCL hash. We use the URL. We use the host header. We create a hash. We look it up. In this case, we don't find it. It's a cache miss. So we follow the blue path all the way to VCL miss. And that takes us to that big gray box, the big gray box of doom, the part that we want to avoid. Because that part involves talking to the application, talking to Volto, talking to Plone. So we try to keep that to a minimum, but when you have a cache miss, you have to send a backend request, which brings us to VCL backend fetch. You have the logic there. The original request is converted into a backend request. And then when a response comes back, you enter in VCL backend response, which executes the logic prior to storing it in the cache, and then you deliver it. A miss is not a bad thing. A miss is a hit that just hasn't happened yet. It's not that bad. A pass, which is the red path, is way worse. That's things that will never end up in the cache. However, if we've done the miss and we store the object in the cache, then we could do this all over again and follow the green path, which means VCL receive, look it up in the cache, we found it, we do VCL hit, we deliver it, end the story. So that's pretty much how it works. And here's a first example of what VCL could look like and how we can extend standard behavior. First things first, we need to set a backend. The backend happens to be on the local machine. Now, in the modern day of orchestration and containers and cloud, this will probably be a separate host name. And what we do there is we hook into VCL receive. We check what the URL is like. We intercept the URL. And if the URL matches a regular expression, and the operator we use to match regular expressions is the tilde that you see in the if statement, if the regular expression matches the admin pages, which is /admin/admin/ or /admin/ and a subordinate resource, we know we're going to need all those cookies. So we're not going to cache that. Return pass which brings us back to, if we go one back, that's the red path. From VCL receive, we decide that this will never be cacheable. However, under all other circumstances, it will be cacheable. The rest of the page is cacheable. So we might as well just strip off all the cookies. And with all the cookies, we mean the functional cookies, but also all that tracking stuff, all the Google Analytics cookies and the HubSpot cookies and all the rest. Now, that's one approach, and that is very tedious because you have to know which URLs are impacted. Another way to go could be look at it from a cookie perspective. If certain cookies appear, we can't cache. So what we would do then is we would intercept the cookie header and see if it is set, which is rec HTTP cookie. So we get a request, it has HTTP headers, and the cookie header is the one we're going to check. We're going to parse the cookie if it is set using the cookie module that we've imported on the second line. And then we're going to say remove all the cookies except the ones that we're going to keep, which are mentioned here. Now, to those people in the audiences, do those cookies ring a bell? They do ring a bell, right? Which, if I'm not mistaken, these are Plone cookies, right? So let's talk about Plone, right? Enough intro. Let's talk about the actual Plone. And as Lucas so eloquently said in Portuguese, I don't speak Portuguese, but I captured the message is we're not Plone experts. And we're not trying to be here on our high horse. We are on a stage. We're slightly elevated. But our message is a humble message. We're here to learn about how Plone and Varnish can work together to get optimum results. Me, myself, I'm not a Plone expert. I've only heard about Plone for a couple of months. Prior to that, I didn't even know this entire community and this entire project existed. So we have to approach it from that perspective. That being said, I did try to set up a Plone successfully and experiment with it. And throughout this presentation, I'm going to share my journey. Now, also important to note, this is a two-part story. This presentation is part one. This is Varnish caching for Plone users. Second part, which happens tomorrow at 2:30, is about once you've set this up and you want to do this at scale, what are the pitfalls? So I am in your territory, in your world here, as a humble observer. And tomorrow I'll approach the role of a more operations-focused Varnish expert that's going to give you tips and tricks on how to scale it. So this is more developer-oriented. And the way I've approached it is I spun up some Docker containers, right? And I learned some interesting things, that there's no such thing as just Plone. There's this thing called Volto. Also something I hadn't heard of. I read up on it. It's a pretty nice front end, to admit. So I spun these up and I had to do some things, right? So we had the Plone backend. I'm using Plone 6. Am I doing a good job by using Plone 6? Okay, that's good. And I set some course stuff and the site name, all of that. It runs on port 8080 on my local laptop. So if I want to access the Plone backend, I'll do localhost 8080. Be one way of doing it. I could just go to localhost as well and just intercept that, but that's the way we went. Then we have the front end, which is called Plone front end, but that's codename Volto. Still agree with me on that one? It's called Volto, and it connects to the Plone backend using an API endpoint. And I noticed two ways of doing it. I could connect to the Plone backend directly, right? Send all the backend API requests from Volto to Plone and not intercepted via Varnish. Or I could switch it up and say, hey, before I actually send it to Volto, why not cache it? Or what? I need to rephrase that. Before I send it from Volto to Plone, why not send it through Varnish and cache those responses? And then obviously we have Varnish as well, where I mount a VCL file that is optimized for the architecture. And I saw two distinct architectures. This is one, Varnish in front of both of them, but Varnish will only cache the pages and the assets from Volto, and the external API calls that are emitted in Volto. We're talking AJAX calls. Or, as I mentioned, route all the internal API calls through Varnish as well. So that being said, we've done that. I spun it up. It worked quite well. I did some observations on the resources that were loaded. Kind of interesting. And the most interesting bit was this one, this AJAX call with the ++ signs in it, which in hindsight caused me a lot of headaches matching regular expressions, right? ++ is not cool. And these are, so when I ran a Varnish log and tried to examine for the homepage what happened, I saw, and I color-coded it for your convenience. So everything in dark blue are the typical Plone resources that were loaded via Volto. So we have the imagery, we have the CSS, the JavaScript, the fonts, the icons, all of that. So this is typically something I would route from Varnish to Volto and cache that. And I also saw this, and I did this in the burgundy color, the API calls with the expand, breadcrumbs, actions, navroot, all of that. I noticed that was called via Ajax in my Volto. So that would be routed to Plone. And then I saw these internal API calls that were prefixed by Plone, which is probably goes back to this. Oh, man, I made myself difficult. Here, that Plone site, it's probably related to that. By setting it, that would be the URL in Plone that we would call. And then finally, I saw a lot of these one-off calls to Plone API workflow at site. So that being said, and knowledge that we've gathered in the beginning, let's enable it. Let's enable caching in Plone and see how we fare. I did not find this in Volto. I had to go to Plone. Is that a correct observation? You can do a lot in Volto in terms of admin, but I didn't find a caching option, so I had to go to the Plone backend. It was already giving me hell for doing that. See the yellow box is like, don't do that, go to Volto. But I didn't find it there, so I did go to site setup. I went to caching, and I saw a lot of cool things in there. Like, to my big surprise, a lot of things are very cache-friendly in Plone. So I enabled caching, which is kind of cool. And then I went into the details, and I needed to set an endpoint for cache purging, which is incredibly important and arguably the most important thing a CMS or a framework can do for the cache. Because putting stuff in the cache is easy. I mean, you have cache control headers. We can override everything we want in VCL. But getting stuff out the cache is the real trick. Hence, the very famous quote by Phil Carlton, there's only two hard things in computer science. It is, and naming things, right? And off by one error, some people say, but hey, who am I? So doing that, it requires a level of diligence. And the community here, and I'm speaking to you as being responsible for all of this, have created native cache purging capabilities. So I put HTTP Varnish in there because that's the name of my Docker container. Then the big point of confusion, and this is where something I would like to have a discussion on, is I needed to select the content types I wanted to purge, which is kind of strange for me because typically when we change something, I don't want to select content types that need to be purged. I want everything that changes to have the right purging. So I just did Control A, selected everything. Not sure if I did that right, but that was my observation. And in the next step, to make life easier, I imported a profile with caching proxy, which already set a couple of content types and associated a type of caching with it. And then as we progressed, we could set those caching types, and those are preset, mind you, for the individual types of content. And I examined it, and I checked what that meant. And from a caching perspective, I saw this. That strong caching will actually set a very long cache control header, which equals 86,400 seconds. Now, I know that that is a day, not because I can calculate so quick, because, pun definitely intended, I cached that amount of seconds, right? There's proxy revalidate, there's public, and there's a last modified header for conditional requests by default, which is a good thing. It's kind of nice. Then the default values for moderate caching I also kind of liked because it includes an E tag. E tags are very useful things. I mean, they behave in the same way like a last modified. We'll get there in a second. But that was kind of cool. What was interesting about moderate caching, and you see it, is that max age is set to 0, which means typically the caches that prioritize that won't be able to cache. But Varnish and other caches are smart enough to see that S max age is intended for the caches. So that means a proxy like Varnish or a competing product or project would cache it for a day, but the browser would not be allowed to cache it. Okay, fair enough. And then weak caching, of course, is no caching at all and must revalidate, so enforcing certain things. And terse caching, something I noticed for the API calls, does very short caches. A minute of caching on the proxy, 10 seconds of caching in the browser, and an E tag. And then I could dive into individual settings, which is kind of nice as well. So I took the one for the dynamic content, which applies thirst caching, and that is what we see. Apologies, the screen is kind of small. I did try to do my maximum, but what happens is you can see the max age of 10, you can see the shared max age of 60 seconds, and you can see the E tag and what type of internal components it uses to compose it. This. And by using these values, those will be emitted down the line in the Ajax call. You could see him right here, E tag W, because it's a weakened E tag for some reason, and then all the bits and components. And I want to talk about that real quick. I want to talk about how that fits into your revalidation and content or conditional request strategy. So typically when you would send a request, you would get a 200 OK, and there would be an E tag associated with that in your case. Plone sends that, which is actually kind of cool because it gives you the opportunity, or it gives the browser the opportunity to perform conditional requests, meaning that the next time the browser sends a request for that very same resource, the E tag is stored under the form of an if none match header. Check it in your browser when you have when you've enabled that. Just see. Don't do a hard refresh. Just call the resource again, and you'll notice that the if none match is being sent. And then, as a clever citizen, Plone will just say, okay, so the if none match header for that resource is this value. It actually is identical to the E tag I'm about to admit. So nothing has changed. So 304 not modified. That's a pretty big deal. That's a pretty good one because that avoids sending payload over the wire. It pretty much says to caches, hey, I know you're trying to revalidate. I know you're trying to fetch something, but whatever you had is still the right content. So carry on. Great. One piece of advice I would give, and I'm not sure if the framework has that built in, is at first sight, at first glance, this seems like a measure you can use to reduce the bandwidth being sent over the wire, which is a justified reason to use it. But if you would have a mechanism to store the E tag that is executed before the entire framework is bootstrapped, you have the ability to exit real early when you validate the E tag and not run the rest of the code. So let's say you have this event hook that hooks into the execution flow real early that can call a key value store, if you will, and return the E tag we know for the incoming request. We could say, oh, if none match equals this E tag, 304 not modified, stop execution. So that means you don't have to bootstrap the entire framework. You don't have to talk to the database. You don't have to do X, Y, and Z. And that's an optimization I would like the community at large to consider. If it's there, then I stand corrected. If it's not there, then I invite you to have a conversation about that. So here's the proof that if none match is added to the request and it returns a 304. Pretty cool. Now we saw other parts of caching that don't rely on E tag, but rather use loss modified. Now, while I'm a strong proponent of E tag, it pretty much has the same behavior. It detects if something has changed not on a fingerprint, which is the E tag, but rather on a loss modification date, which is pretty easy to track in a CMS. I mean, you probably keep track of change timestamps and last updated in the database. Could also store that in a key value store that is super quick to access and that is executed real early. Gives you the opportunity to do an if none match, a 304 not modified, yada, yada, yada. And you can set that again by clicking the option. Last piece of the puzzle here is the vary header that I see here. A vary header. Who's heard of a vary header before? A couple of people, right? It gives you the opportunity to do cache variations. A cache variation means that you're storing separate sub-objects of a resource based on a request header. Let me give you an example. Let me show you the header. So if we go back, vary accept encoding. The values of this response header are valid request headers. So out here you see accept. What do we accept? We accept application JSON because we're doing an AJAX call. If the value would differ, you have different sub-objects. Accept encoding is something that Varnish adds to say, hey, this is gzip, but if you as a browser don't support gzip, we will store a plain text version of it in the cache. And this is a more an easier way of seeing it in a diagram. So let's say a user sends a request for the homepage using AJAX, it's application JSON. We will see it. We will return it with a 200 OK. We will use a cache control header to say how long you could cache it. And at the same time, we will say, please apply a cache variation based on the value of the accept header, which would result in a JSON version and maybe a text HTML version, if you will. That's very useful as a concept, but I wonder why this is being done in Plone based on the accept header. Because is it going to change? Is the representation of the output going to change if the browser doesn't support application JSON? It's a fair question. It's something that could be addressed. Because you're not going to return an AJAX call returning JSON all the time if the browser doesn't support it. So what would the alternative be? Text HTML? I don't know. I see the value of using a vary. I just wonder if accept is the right approach. But you could use it for languages. If you have multilingual support, which I saw an article on, Plone has it, you can do vary accept language and leverage the accept language header for multiple languages, in this case, Dutch and English, for example, and store those separately. There's tremendous value in that. There's also risk involved in using cache variations. Because if you change a value, like security 101, never trust a browser, never trust a user. If you start sending random accept headers, you're going to poison the cache. Something you need to keep into account. And unfortunately, the HTTP protocol is not equipped for that. So you need to clean up those accept headers. And that's where Varnish comes into play to help you along with that. Here's a module that we offer called the accept module. And it is done to filter down to a white list of accepted accept headers or accept language headers. So here we initialize in VCL init 2 sets. One called the format with the supported formats. So when we create that object with accept.rule, we say what the fallback is. And the fallback is text plain. So if anything fails, we will revert back to text plain. And then we support text HTML maybe, application JSON, text plain, whatever. We do the same thing for the languages. I have 5 more minutes apparently. Seriously? 5 more minutes? All right. Okay, let's carry on. So in that case, we do the same thing for the languages. And then in the end, we inject those in the accept language header and override them. That's how we operate. And that will reduce the amount of variations that you have, reduce the cardinality of the cache, will improve your hit rate. Big one. So I mentioned that one. Only 2 hard things in cache, in computer science, cache invalidation and naming things. We call that cache purging. Cache invalidation means making something invalid. Cache purging is forcefully removing it from the cache. And the way we would do that, and that's the way the VCL in Plone works as well, is by using a purge request method. You use that request method to identify the action you want to take, and it's a very deliberate action. It is invalidating the cache. But you don't allow it for everyone. So you add a whitelist with IP addresses, subnets, and host names of systems that are allowed to do this. And then you're in a possibility to do maybe via curl, example.com/contact, use the -xpurge option, and it will remove it from the cache. Remember this one? This is what you guys do underneath. You leverage purge. So when I would open up Volto and would change something in my test page, this is what it's going to come out. These are all the endpoints that you're invalidating. And I say you, I'm not pointing out individuals. I mean you as a community, as representatives of this project. This is what's going to happen, which is kind of interesting. And I wonder what all of these mean. But I do know there's an issue. The issue being you invalidate, for example, API/test, third to last item, and yet this is the one we're going to call in the browser. And mind you, the query string parameters are also part of the URL. So this won't be invalidated by default. I also see internal API calls without the Plone prefix being sent. Also kind of interesting. So the way I approach this, and that's the way you seem to be approaching it as well as a community, is by using the virtual host monster to turn this into something that matches. So even if we do /API/test or /Plone API test, we would result in the same URL, and that would result in a cache hit. So I had to adjust the purging VCL. Now, apologies, I try to maintain a font size of 30 because I know that's readable. But this screen is kind of small, to be honest. And we can talk about that later. 3 minutes, they say. So what I did here is I did set the virtual host monster right here for Plone API and just for regular Plone calls. Make sure it's the same. And then I checked whether it's an API call. If it's an API call, then I'm doing a regular expression substitution on the plus and turn it into // because otherwise we have pluses in a regex and we know that's kind of tricky. And I try to match that. If it's not an API call, I do an exact URL match to invalidate it. And then we have the rest of the stuff. So yes, there's a full VCL. I'm not going to go into detail since I only have 3 minutes. But there's a whole lot of VCL I wrote to keep this working. And I'm not 100% sure it is the right way forward. And I was particularly interested in improving the purging aspect of those API endpoints. And I want to leave this, or leave you here, with one idea. I see that other communities, non-Python, like I see that the Magento community, which is PHP related, the Drupal community, also PHP related, abandoned the idea of focusing too much on URLs as a mechanism to purge, and instead focus on content tags. I mean, there's a lot of metadata that you can associate. And I hope going forward, I did a pretty simple attempt of actually normalizing the URL and trying to extract certain values from it and use that as a key. So set tags based on URL endpoints. It's a bit of a hard-handed approach where we try to identify whether something is an API call or not. I also add an all key if you want to flush the entire cache. You can use the all keyword. We're using the full URL, but what I'm also doing is trying to get that last part of the API call, just the path, and stripping off the query string parameters and registering that as a tag. At least when you do the purge, you will hit all those. So it's a bit of a quest. It's not exact science. So I'm actually trimming off the query string parameters to have a tag that is the pure URL of the API call. And then you can do some clever stuff, which is kind of unrelated, but still fun, is if you have images in Plone, there's this weird notation with at images and all the other stuff. What I'm trying to do here is take the first bit, which is the JPEG or the PNG file, and register that as a tag. And in the end, we'll leverage, I have 1 minute left, ladies and gentlemen. We leverage grace mode to enable soft purging, which is something that is also missing in open source, allowing you, if you want, to actually, rather than remove something from the cache and having to deal with the consequences of the onload of traffic, on the on-ramp of traffic, just mark something as expired. And then, I think I'm in my last 30 seconds, we can actually leverage asynchronous revalidation, which is a big plus. So you could send stale content to the user while there is an asynchronous fetch happening to update the cache, which gives you the opportunity to save on resources, but also save on user experience, because the end user is not going to see the delay because we're waiting for Plone or for Volto. You'll be serving the old cache, we'll revalidate it, and use these equations for which we don't have time, but it's actually, by doing the invalidation, you're setting, let's go here, by soft purging it, you're setting the TTL to 0, and you rely on the grace value in Varnish to do the asynchronous revalidation. This being that, and having the ability to do this in Plone yourself, if you want to, by just figuring out a way of including this into the caching infrastructure that you offer, offering stale while revalidate keywords. There's a lot of keywords in there that I really like. It's brilliant. This could be one that you can add. And there's a lot more stuff, like enterprise features, really cool things that I'm not going to talk about now, because that's a story for another day. That other day is tomorrow. So I kindly invite you to take this to the next level. This is Varnish for Plone developers. This is a very basic 101 with a couple of observations, more questions and answers, to be honest. I want to invite you there, and we'll take it to the next level with more operational perspectives and looking at this from something at a large scale. But I also want to invite you to make the VCL better and think about caching together. Thank you very much. I still owe you a book. Grab it if you want to. Muito obrigado.
Thank you, Zeis. And everyone, someone have any questions about the talk?
I tried to dodge questions, but because Champions League's already 15 minutes in, but hey, I'll answer questions.
So I have a question about the Varnish load balancer. Is better to use Varnish load balancer or use a dedicated like HA proxy? Or
I'm very, very biased in this matter. I have tremendous respect for HA proxy because it is a true load balancer. And I love HA proxy and what was it? Is it Willy Tarot that built this? I love what the guy does. However, we have all those capabilities in there. You don't need to do that. We have really good load balancing infrastructure in play. I haven't showed this now. I'll show a little bit of it tomorrow if you're interested. We can do sharding. We can play around with really interesting things. We have an active DNS module that can do service discovery, that can do DNS-based load balancing. And if you've seen it, you can actually intercept certain requests and say, well, if this is the context from an HTTP perspective, we'll route you there, which I'm not 100% sure you can go into those depths in HA proxy. Not discrediting HA proxy because it's a brilliant project. So if you would ask me personally, I would say use Varnish if you already have Varnish because it has the capabilities to do so.
Okay. Thank you.
Well, hello. I'm going to mimic the same question was made before about Volto. I will ask you the same. Since you are, you you name it yourself as not an expert in Plone. I would like to ask your personal opinion about what you think on regarding caching in general in Plone, and how mature you think we are today.
I think you're quite mature, to be very honest. I see a lot of similar frameworks and content management systems that have way less in terms of caching in there. The fact that I was able to show you these amounts of screenshots, I know they were kind of small, apologies for that, but these amount of screenshots with cache native stuff means that you're super advanced in this. Well, super might be an exaggeration. Very is the word. You're very advanced. A lot of the cache primitives that are part of the HTTP protocol, I could find there. I did voice some questions and some concerns, like why are you doing vary except? Maybe there is a perfectly logical reason for it. And I gave you some pointers, like why not use stale while revalidate in there as well. The only thing I'm a bit annoyed with, and you saw that, is that I had to go to great lengths to sanitize the URL to match a URL I could invalidate that was actually called. I mean, ++ API/test, which is my test page. Okay, great, we've invalidated it. But you're not calling that URL. You're calling the same URL with a question mark and expand and all of that. So that does not make sense from a caching perspective. And maybe we can do a better job at fixing that. Or maybe, as I suggested, if there is room for that within the community, shift to a more tag-based approach, where you look at it from a content perspective, associate tags with a specific piece of content, and invalidate the tags rather than the URLs, and know the right pages will be removed. That would be my personal preference. But yes, the community is very advanced in terms of caching.
Thank you. And thank you. Thanks, this is recorded, right?
First of all, thank you for the talk. It's very interesting to see for an external approaching Plone and the Volto system, as still a lot of people are using Plone with Plone Classic. So the internal UI, it's a bit different sometimes. And also a great thing where Plone really shines are intranets. And caching with intranets is also a very fantastic thing. Yeah. And especially the parts that you can do split view caching and just separate the parts of the element that should be visible to all the members, even if they're logged in, and just separate the parts out where the username and so on is shown. And do you have also some tricks to show for those use cases maybe tomorrow?
Well,
or during the sprint?
Maybe, yeah, we might cook something up. So what you're pretty much saying is that you want to see something different if you're logged in versus non-logged in, correct?
Indeed.
Well, the danger would be, this is something that people would do. They would do vary cookie. Vary cookie is quite dangerous, so I'm not a fan of it. So what we could do is set a custom header called vary or x logged in maybe, and vary on that. As long as we set the header in Varnish or in a system before it, we know this is a logged in user, this is not a logged in user. We can write the logic ourselves. We can check the _ AC cookie. Is that the way to go? Well,
no,
if that cookie,
I would more go into split view caching and edge sites include and
yeah, that kind of stuff. We can talk about that later on. I'm interested in the. I have no awareness of it right now, but I'm sure if we interact, we will come to some sort of a conclusion and a solution.
Thank you, guys. A round of applause for Chase, please.
I really enjoyed that. Thank you.